Good morning, good afternoon, depending on where you are. My name is Janet Halliwell. I am moderating this session, and on behalf of CSPC, a very warm welcome to everyone. Now, we've got some technical issues today with one of our panelists not having video. I'm in a power failure, so running on battery, or at least generator. At any rate, with that being said, we are going to be participating in a very exciting conference session with the title, The Promise of Convergence Research, the Readiness of Canada's National Research Facilities and Academic Partners to Support Policy Responses to Grand Challenges. And this is organized by the Centre for Science and Innovation Policy, CSIP, at the Johnson Shoyama Graduate School for Public Policy, University of Saskatchewan. And Peggy, who is our mastermind for this session, is the one that we will not see on the screen, unfortunately. But before we begin, a couple of housekeeping items. Please turn off your videos and microphones, but do note that the session will be recorded. Also, don't forget to tweet about your favorite events and panels at the conference, hopefully this one, using @SciencePolicy and hashtag CSPC 2020. So without further ado, let me now begin the session. First, and an important bit of context, there's a short background discussion paper or green paper on the website in the session description, and that lays out the background to today's discussion. Please do download it. It's either now or following the session. So let's talk a little bit about the structure of this session. My introduction is going to take a 35,000-foot approach to the issues and our targeted outcomes, also introducing the players around this table. And during this introduction, we are going to ask you a couple of questions about who's in the room and what motivated your participation. So you'll have a chance to tell us a little bit about yourselves. Then we're going to hear short presentations from each of our four panelists, providing their experiences with convergence research enabled by national research facilities. That's going to provide the substance for a Q&A session scheduled for about 25 minutes, after which we're going to move to another form of interaction, rapid polling, that my co-moderator, Joelena Leader, is going to moderate. And that will be looking at some of the particular issues and your suggestions in terms of how you see the landscape for the national research facilities. And that will lead to a wrap-up discussion on the next steps. Where do we go from here? So you're going to have two ways of interacting with the panel. There's the Q&A button on the screen that you logged in with, and it's also noted, I think, on the upper left-hand side of your screen. But please don't hesitate to enter questions while our panelists speak. Don't hold back. And the poll questions are going to come up on your screen. Just click on one of the multiple choice answers. You'll have to make sure you go onto that to the answer questions. The results are going to come up on the screen in real time. And so we're going to start by the first question, and note you can only select one response. Choose which best describes you. So our first question is, what sector do you represent? Government, industry, private sector, academic, that can be social sciences and humanities in the first round, academic, natural sciences and engineering, we'd like to be able to parse this community, research community and facilities, or other. So hopefully we're going to see some results, some input. And while we have people hopefully responding, let me just go on to talk a little bit about our session. Aha, we are getting some responses. We have a lot of government people. We have a mix of all other sectors, and interestingly, a nice contribution of social sciences and humanities as well. So our focus today is going to be on the capacity, preparedness, and needs of our national research facilities to engage in convergence research. benefiting from 3 specific case histories of successes and the associated challenges and barriers. Before I go on, let's bring up the second question. Why did you join us today? And so we're interested in whether you're engaged in convergence research, you're curious about convergence research, you're looking for collaborative opportunities, you're looking for models or policies that support convergence research. You're not sure, but you thought it might be interesting. So lots of different rationales. So while I speak and go on a little bit further, we'll see how the outcome of this comes up. Curious about convergence research, looking for models and policies. We've got a good selection of motivations. Great. Okay, so as an outcome, we are seeking collective insights on how we can create an ecosystem for enabling our NRFs, National Research Facilities, to participate even more fully, efficiently, and effectively in research that is, in the words of CFI, research that is aimed at specific and compelling problems, requiring the deep integration of disciplines, knowledge, theories, methods, data, and communities. In this type of research endeavor, merging ideas, approaches, and technologies from widely diverse fields of knowledge at a high level of integration is a crucial strategy for solving complex problems and addressing complex intellectual questions. So in our discussions about the theme of this session over the next, say, 80 to 90 minutes, I'm going to ask that you give consideration to 3 key dimensions of what we are calling NRFs, National Research Facilities. So let me parse that. National. While we describe our NRFs as national facilities, they are also international in character, providing important knowledge and capacity conduits among Canadian and international researchers and other players. Parsing research. When we think of the communities associated with NRFs, we need to get beyond the traditional view of researchers in the natural sciences and engineering and health and their hard, I'll call it hard, scientific outputs. So let's broaden our horizons to include the social and human sciences and the prospect of larger societal engagement. And the final word, facility. National research facilities are more than physical facilities in my mind. They're best characterized by the core capabilities and capacities embodied in their human resources, their people. And associated with this is their ability to imagine new and exciting utilization of their physical and human capabilities. So in essence, I've taken each of those 3 terms and redefined NRF, National Research Facility, or perhaps at the very least deepened our appreciation of just what we might mean by that term, NRF. So we're going to talk about how NRFs have engaged in convergence research, the power and impact of such approaches, as well as the challenges and barriers. And in the latter parts of this discussion, we're going to focus on what changes would better enable these premier research resources to contribute more efficiently and effectively to our intellectual, social, and economic well-being. But enough from me. We have a rich selection of talent around the table, people that I'm going to introduce together now in the order in which they're going to speak so that we don't break the flow of presentations. And my introductions will be brief. Peggy Schmeiser. Peggy is Associate Director, Centre for the Study of Science and Innovation Policy, CSIP, University of Saskatchewan, and the mastermind of this session, even if you can't see her face. She's PI for a study on the very theme of this session, convergent research and national science facilities. Our second speaker will be Nigel Smith. Nigel is Executive Director of SNOLAB, a position he's held since 2009, since moving here from the UK. An astrophysicist by training, he combines a career as a researcher and a facility leader in one of our best-known NRFs. Kate Moran is the President and CEO of Ocean Networks Canada, our remarkable cabled ocean observatory. Formerly an Associate Dean at the University of Rhode Island, Kate served as an Assistant Director in the White House Office of Science and Technology, where she focused on Arctic, oceans, and climate policy issues, all big, grand challenges. Dean Chapman. Dean is Professor of Anatomy, Physiology, and Pharmacology at the University of Saskatchewan. He's a former CRC in X-ray imaging and a former Scientific Director of the CLS, the Canadian Light Source, Canada's synchrotron radiation facility. And finally, my co-moderator, Joelena Leader. Joelena is a research facilitator in the Edwards School of Business and Professional Research Associate with CSIP, bringing a background in sociology and interdisciplinary studies. So over to you, Peggy, to lead us off.
Thank you very, very much, Janet. And just echoing her indication that my camera's not working, but I'm delighted to be here. I apologize for that, but at least I can be with you in voice and with the slides. So again, thank you very much, Janet, for your introduction, and thank you to you and to everyone else on this panel for agreeing to join us for a discussion that I think is both very important, but also very, very timely. I appreciated, Janet, what you shared about what we mean by convergence research, so I won't dwell too much here. But just to say that I do think we are seeing increasing convergence, pardon the pun, or consensus about the need for us to find ways to work across not just disciplinary boundaries, but sector boundaries and even different knowledge systems in an effort to try to find solutions to the scope and the complexity of the grand challenges that we're facing, whether they be related, for example, to climate change, if we think of COVID-19 and infectious disease, food and water insecurities. I think there's growing consensus about the importance of convergence research. As Janet mentioned, I've had a real privilege over this last year serving as the PI for a project that's entitled Advancing Convergence and Collaborative Research through Major Research Facilities. And I'm pleased to say that Dean Chapman and Joelena Leader, who are also part of this session, they've been really critical partners in this work along with others. And this project is being funded through the Sylvia Fedoruk Canadian Centre for Nuclear Innovation. And our team could not be more grateful for the support that's enabled us to look at this question of the capacity and the preparedness of Canada as a nation, but in particular our national research facilities, to engage in this sort of research in the hope of bringing better solutions, better policy solutions. As you'll see on this slide, we've been engaging with a number of national research facilities. They include Triumph, SNOLAB, Ocean Networks Canada, the Amundsen Icebreaker, the former Canadian Neutron Beam Centre, the Canadian Light Source Synchrotron, and the International Vaccine Centre with the Vaccine and Infectious Disease Organization. Through discussions with individuals from the research communities at these facilities, as well as from the leadership teams at facilities, as well as from the universities that are associated with some of these facilities. We've been looking to identify models of convergence research, as well as the barriers and opportunities that we see arising from this form of collaboration. What we're looking ahead to do is hopefully disseminate our findings in the coming months with recommendations that we hope will be of significance to the policy sector, to the research community, as well as I mentioned earlier, to leadership teams at universities and at the facilities themselves. Because we're still at the stage of our data collection, we should be winding that up very shortly. I did still want to share with you what I would consider some preliminary observations. I won't go into too many details, but just some high-level observations at this stage from our work. First of all, as I've indicated here, there seem to be huge gaps and a real appetite for more research on major research facilities. We've had a very, very positive response to this research, And I think that also says something about what we need to think about in terms of science policy in Canada. Secondly, we have been hearing about extensive models for convergence research or examples of convergence research. Other panelists will be talking about that shortly, so I won't say too much there. But as well, thirdly, there's an overarching desire that we're hearing to collaborate and to contribute to resolve large-scale problems. I think there's a real sense among our research communities that they're an underutilized resource in the country, and that they're subject, in fact, to a number of constraints due to certain policy and governance obstacles. Again, something for us to think more about. And then finally, along with hearing about a variety of governance and policy challenges facing the research facilities and the research community, we're hearing about a number of recommendations and things that we've been able to formulate, as I mentioned, that we're hoping to share in the very near future. Lastly, and as part of just this very brief presentation, I wanted to just highlight where I think we're going in this discussion about convergence research. I think there are three things for us to think about, particularly as we look ahead. One is the question of Canada's policy approaches to major research facilities based on the full life cycle components. How do we as a nation decide what sort of infrastructure we need? How is it going to be funded, and what sort of models are there for ownership and for management of the facilities? Secondly, I think we need to give a bit more thought to the policy and governance factors and the relationships in particular that impact the research that we're able to undertake. There are a number of things that can impact this: relationships among ministries and agencies at the federal level, relationships between the federal government and the provinces, universities, and then of course directly the major research facilities with all of those different levels as well, and how that impacts research itself. And lastly, I just wanted to mention the importance of public engagement and support. How do we work to either restore or in cases maintain public support and confidence in science, and therefore public support for the sorts of large-scale investments that are required as part of our major research infrastructure landscape or ecosystem? So I just wanted to throw out those three particular ideas of where I think we might need to go as we think further about these issues. And I'll stop now, and if there are any questions following the presentations, I'd be happy to engage further. Thanks, Janet, and thanks everyone else again.
Thank you so much, Peggy. Now over to Nigel.
So thank you, Janet. So what I'd like to do today is give you a couple of examples which reinforce some of the messages that Janet and Peggy have already provided. And the key messages that I want to reinforce is that the national research facilities, we stand ready as an agile resource that have many varied capabilities and talents that we can bring to bear on any grand challenges for the nation. Also reflect that the national research facilities are national assets, but they act as gateways to the international community. And I think one of the examples will show that very clearly. Convergence research is something that we've been engaged in some sense at SNOLAB for some time. But just to give you some handle on what SNOLAB actually is, we come from the astroparticle physics background, originally created from the Sudbury Neutrino Observatory, which is the project that Art McDonald led for many years and solved the solar neutrino problem, which eventually led to Art getting the Nobel Prize in 2015. And following on from the success of SNO, we were able then to create SNOLAB, and that was the mechanism for generating a national research facility from a single experiment. From that point, we have broadened the research that we're engaged in, and we have started looking at some of the interdisciplinary convergence issues and looking at where we can get mission-driven challenges. And a point I think I'd like to make is that mission-driven challenges can come from several directions. There is the government policy approach, but there is also a research community approach. And in particle physics, particle astrophysics, we are used to working with strategies that have been put together by the research community to define those mission-driven challenges. So the sort of examples that we've had at SNOLAB demonstrate that convergence research, interdisciplinary research, arises in two ways, either through serendipitous meetings or this mission-driven, this approach from a research strategy. In terms of the serendipitous approach, one aspect is that once you have a platform like SNOLAB, once you have a research facility which has a broad range of capabilities, through personal contact, through basically information getting out into the community about our capabilities, we found that many researchers recognize that we can support their research, and they have approached us in various ways to look at bringing their research to SNOLAB. So the sort of examples we have here, for instance, fall under the genomics and deep subsurface biosphere type of work, where we've had two projects. Genomics obviously is not why SNOLAB was created. It was created for astroparticle physics. But because of the capabilities that we have, the chemistry we have, the fact that we're 2 kilometers underground, the researchers in some of these areas around genomics and the impact of, for instance, radiation on cell mutations, recognize that we have capabilities that they can utilize in their research. The other approach is the mission-driven sort of approach, and here COVID provides a very clear example with the MVM ventilator. That was a project that was generated from some of our research community who are exploring, they're looking for dark matter, exploring the universe, and they're using a detector that uses liquid argon, which is a cryogenic detector. But one of the Italian researchers, and this is where the international component comes in, one of the Italian researchers during the first COVID wave recognized that the techniques that have been developed in this type of research were actually applicable to creating a new type of ventilator. Well, it's an old ventilator, but it's bringing a new way of doing it to the table. He approached Art McDonald, so this is Cristiano Galbiati, one of the collaborators here, and he approached Art McDonald, who then brought in 3 of the national labs, Triumph, Canadian Nuclear Labs, so Chalk River, and SNOLAB, and also the McDonald Institute at Queen's University. And we were able basically to pivot the research we were doing because of the capabilities that we have. We were able to pivot the research to address this problem and very rapidly convert what was an idea from Cristiano into something that gained initial approval in the US for use, for emergency use in 6 weeks. And following on from that, we've developed the concept and now have Health Canada approval, and it's actually manufactured by Vexos and JMP Solutions in Ontario. And so the convergence there, we had a mission. It wasn't a top-down in the traditional sense, in that it was not one handed to us by government, it was handed to us by our community, but we were able to pivot quickly, pick up with that mission, and drive it forward because of the capabilities that we have. So the NRFs, as Janet mentioned, we are a long-term agile resource that can be turned to grand challenges, to any issues that arise. We are national assets, but we do act as a gateway to the international community, and we are capable of addressing not just academic fundamental research, but also mission-driven challenges. Thank you. Back to you, Janet.
So thank you very much, Nigel. So on we go to our next panelist, Kate Moran.
Thank you very much, Janet, and thank you to all of my cohorts here. It's a pleasure to be with you. I think my slides are shown here. I'm just going to start by just giving you my perspective. I'm the CEO of Ocean Networks Canada, and from an ocean perspective, people sometimes think of oceanography as just one science, but it's actually convergence all over it, because it's physics and chemistry and biology and forensics and every aspect of everything on Earth in the ocean. So it's inherently enabling convergence research by allowing scientists to use different systems, but in the same location and converge on their research for new discoveries. In terms of what we operate, this is just an image of most of our infrastructure, the telecommunications cable under the ocean. We have our deepest site around 3 kilometers, our shallowest site about 100. But what this represents is one of the most diverse footprints of the ocean of any place in the world. And so because of that, we have users of this facility nationally and internationally that get the data in sometimes in real time, sometimes later, but openly over the internet. And about half of our users are national and half are international. It speaks to the point that Janet raised in the beginning. We deliver this infrastructure as a major science initiative, just as Nigel talked about on SNOLAB. And so the researchers that use our infrastructure do it for basic research and applied research, but we also, as an organization, through our capacity, are able to combine data with models to deliver products not only for the research community writ large, but also to help federal mandates deliver in terms of science mission-driven departments deliver on their mandates as well. So we provide research, but also broader benefits to Canada. In terms of, we are about 168 people strong, and that allows us to continue to innovate. And we sit in a space internationally where we're world leading, but because of the funding model where we continue have to carve off what we do for funding, match funding security, we are at risk for not staying at that international acme. I'm just going to now go through a few examples just to highlight some of the convergence that's come out of Oceanics Canada. The first is the fact that we have been able to use our funded infrastructure to actually do some of the kind of work that Nigel was talking about. The high energy particle physics community has wanted to continue to, let me back up a bit, has wanted to continue to actually detect neutrinos in areas of the ocean. And they came to us because of our know-how and capability in order to actually support the sensors that they already developed. And what's very interesting about this example is that we were able to meet with the scientists, design, build, and install a test system within 8 months. And in fact, it actually has benefits to oceans because we can also use it to study deep ocean bioluminescence in addition to supporting the high energy particle physics community. In terms of our second example, it's about technology again. What we did here in 2012 was we installed a small observatory in Cambridge Bay, Nunavut. And it was, for us, it was to test the technology. Could it work in this environment? Could we deliver data over a really small data pipe? And we were able to do those things, but what came out of it was the fact that we put a sea ice thickness monitor on it, and the community wanted the data in real time. They wanted to know how thick the ice was so they could do their own make their own decisions about traveling out on the ice, whether it's to go take a shortcut to the airport or to go out for hunting or recreation. And so then we began to really see that what came out of this was not only a technical convergence, but the fact that we were able then to deliver to a community. And so this started us down the path of delivering community programs to many, many First Nations around the country. And this is an example in support of Transport Canada's very successful and recently developed enhanced maritime situational awareness program, where communities are collecting their own data for not only the program, but for their own decision making. And then the third example is really about these grand challenges. This is an idealized plot from the UN Environment Program. It's years on the x-axis, but that gray area is showing that by somewhere around 2030, 2040, it will be essential for us as humans on the planet to begin to remove CO2 out of the atmosphere, to keep the planet at 1.5 degrees and avoid climate emergency runaways. And so as an organization that's innovative, we decided that what we wanted to do was take advantage of one of our locations. We've been partnering with Columbia University because they decided Oceanics Canada had the ideal site to test the ability to actually put CO2 into the subsea floor in ocean basalt. Because we have that great location, boreholes already there with sensors in them, and the fact that we can deliver real-time monitoring brought us to solid carbon, where it's a feasibility study to put ocean technology together with direct air capture, and then pump the CO2 down through the water column into the subsea floor. And we hope our next step will be to demonstrate it at our Cascadia Basin site. We wouldn't be able to do that without the fact that we have the people, the technology supported through the major science initiatives, and in fact, our ability to innovate through those people that we support. And so we are now in a feasibility study, and we hope in the next phase of it, we'll be able to conduct a demonstration, as I said. We have many partners, and this is growing. And what's very exciting about this project, it's a big idea that's bringing engineers, natural scientists, and social scientists together. And the big idea is bringing the most diverse group of students and postdocs that I've ever seen in my entire career. I'll close by saying there's challenges. I mentioned the first one, that we need to have secure funding and longer term funding to ensure these facilities are there. As Nigel said, you can't innovate and deliver on missions if you're not already sitting there. As an example that we did for COVID, a scientist then at Dalhousie University looked at and was able to publish the reduction in noise in the ocean because of COVID and the reduction of traffic. But we also need to work on how do we help get convergence in partnership with federal science departments that have specific missions but don't necessarily work together. I think we need to be able to train our leaders to take risks, and we have to allow risk-taking and allow failure to be part of success. We need to focus on some moonshots. As I mentioned, our big idea with solid carbon is one that attracts young researchers. And among these three different groups, there's lots of language differences. I know them in my own organization. We have to overcome. And I want to please, my one big thing in my organization is to ban acronyms, because if we don't ban them, we won't be able to communicate with each other to do convergence. Thank you.
Thank you so much, Kate.
Thank you so much, Kate.
On now to Dean Chapman.
Thank you, Janet. And I want to thank Peggy for bringing this group together and dragging me into this convergence research project that's afoot now. So as being the former science director at the Canadian Light Source and also a guy who built a beam line there, the Canadian Light Source has 22 beam lines. These are experimental stations, research facilities, if you will, that span a very wide range of research capabilities. We have about 60 PhD scientists who man those beam lines, a very international community. There wasn't a synchrotron in Canada prior to the CLS. So it really attracted a very international group of scientists who man those beam lines. And it's as a facility, it's also a very international facility in the sense that we, the community is about 30 or so synchrotrons of our class in the world, and we communicate with those facilities quite regularly. The scientists themselves are primarily there for user support. I think there's an opportunity for using those scientists to reach higher than they presently do now. I'll talk a little bit about that in a bit. Also, I think one of the things that came up in discussions with Nigel is that many of our facilities are community driven. These are high flyers who propose beam lines for us, and then we build those beam lines. But we miss this opportunity of having, I call them missing wrenches, facilities that we could have as a facility that might be of better utility to the scientific community, that are very hard for us to get funded because they're more normal. So I think there's a lack of our ability to adapt to the needs of the Canadian community because of that. So based on the beam lines that we do have, and also being a former beamline scientist, if you go far back in time, I was a beamline scientist at another facility in the States. But I think there is an opportunity to use our scientific talent to address problems that go beyond what a user facility would normally do, which is just do science for users, and we call that solution provider. So we have scientists who span a wide range of science backgrounds, from advanced materials, medicine, bio-life sciences, environment, energy. We have a number of scientists working on various aspects of the COVID problem, certainly the structure determination of the virus itself and targets for that, but also using imaging to look at some of the aspects of masks and how to make them better and be able to recycle them better. But going back to the solution provider, it's to open up to the Canadian community the ability that we have all of this talent and bring to us some interesting problems and beyond things like COVID. And I think it's one of the wasted resources that these facilities have is we attract these very good young scientists to run the beamlines, but then they're left to not have opportunities beyond just Uber user support. And as the CEO of the Canadian Life Source, Robert Lamb, calls them gas attendants. And so to be able to fly higher than just do other people's science. So I think that's one opportunity that's missed. And so I think that part is something that could help advance science at these facilities and have more of a mission-driven activities than being driven by primarily by the community, which is not bad, and it built a large amount of the resources that we do have, but it limits our ability to attack larger problems. So at that, I'll stop and give it back to Jen.
Thank you so much, Dean. Let me just remind our participants to enter any questions they would like in the Q&A section. Please don't hesitate, don't hold back. There's lots of interesting insights that are coming forward, and what are we hearing? I guess the innovative power of the NRFs. Oh, sorry, Kate, an acronym. I can't do that. National Research Facilities. So that innovative power to bring to bear resources, technologies, personnel on grand challenges, perhaps aligned with their core mandate or pivoting in the context of things like COVID. Imagining new relationships with Indigenous groups, for example, non-traditional communities and partners, launching collaborations across domains of activity that in the past have had very little interaction. So convergence is really extraordinarily diverse in its context. It's what I call cross-dressing in so many different ways. And there's sort of insights on what's important for these facilities to optimize their engagement. And I guess some of the words that stick in my mind are capacity, the strong and empowered people, openness to new partners, broader domain interactions, preparedness. So that's a long-term vision, ability to pivot and plan, flexibility, and the relationships. But we're also hearing some challenges. Relationships between the facilities and receptors, particularly government operations that can be very siloed. Need to strengthen those interrelationships. The insufficient flexibility in funding and planning structures, the need to look at life cycle, language differences, and how do we overcome those? The lack of ability to adapt that is sometimes put in place by sort of structures. So some of the issues that we're hearing, any comments from my panelists at this stage before we move over to a few questions? Seeing no hands, people can leap in if they wish.
So maybe I will contribute to this, Janet. I think one of the words that we haven't really heard much about is stewardship, and stewardship of the national research facilities in terms of a federal landscape. So SNOLAB is funded through the CFI MSI program, and CFI have been fantastic at being able to support the development of SNOLAB as we have looked at broadening our research capacity and changing some of the fixed requirements of the MSI program, so allowing us to develop capacity rather than just keeping the lights on and the lab clean, allowing us to look at developing some of the capacities that we require for our research community. So I think the stewardship that I'm looking at, though, is obviously CFI now supporting our operations, having been instrumental in the support for the development of the facility. But the full life cycle that you mentioned, I think, is critical. So it's not just the construction and the operations, it's also the science. How do we support that science program? And therefore, have that knock-on effect of being able to support a convergence program. And none of the national research facilities are afraid of a life cycle, and that's all the way through to the decommissioning phase as well. I mean, obviously, we realise that we have to have a mandate which takes us from construction through operation and supporting science to that decommissioning phase. But having stewardship of that so that there can be a national dialogue of what assets and what facilities and platforms the country requires and needs to develop, I think, is a key contribution that we should look at.
And thinking of stewardship, it was just yesterday that the principal scientific advisor for the government of India noted in a CSPC discussion that he considered the Prime Minister's S&T Advisory Council in India as being a really important entity in dealing with grand challenges. But I'm wondering to what extent do you see a need for something like this in Canada? And I address this to all of the panelists, particularly something that a body that might deal with big science and national research facility issues. Maybe Kate, I'll turn to you first.
So, Janet, just could you repeat what the Indian representative said? Just for my benefit,
It was a comment that he saw the Prime Minister's Science and Technology Advisory Council being a very important element in dealing with grand challenges. We don't have any such thing in this country. Now, we did have something, but it wasn't a body that dealt publicly. It was much more internal. But I'm thinking here, particularly a body that has what I call an internal and an external presence.
Yeah, I think I have to say that, I mean, even though right now in the U.S. it's not like it was when I was there, but the actual structure in the U.S. is an interesting model. And that's where, as you said, Jan, I worked in the Office of Science and Technology Policy, where there were representatives in that office from federal departments that had science mandates and other mandates. It crossed all the sciences. But it also brought in secondments like myself from academia that were there. But the role of that organization, that part of the White House, was to actually pull together the strengths across departments to address some issue. I was on the group that addressed the big terrible oil spill. And we were able to, in a short amount of time, bring all the federal departments together and academia. So if we can find a way to have that kind of structure, it's a different government structure, of course, but that kind of structure, not just an external advisory, but a team that actually is representative and has the levers to bring these different entities together, it could be very powerful.
Nigel, your perspectives, and then I'll go for Dean.
I would certainly agree with Kate that the concept of having an advisory group that looks at the requirements on a national level and advises the government is very strong. I think something that one of the issues that I think has already been mentioned this afternoon is how do we create the infrastructures that exist, and it's been driven by very dynamic individuals who have got a very specific question that they've been trying to address. And that is one model. Obviously, it's very bottom-up way of doing this. And something that an advisory panel would allow you to do would be to introduce a perhaps top-down mission-driven lens to this as well, in terms of setting up infrastructures that would be able to address some of these grand challenges. I reiterate, I think mission-driven sometimes does get confused with the government telling you what to do or defining what you have to do, and that's not actually necessarily the case. You can have a mission driven from the community through a strategic planning exercise, and that's certainly something that the physics community, the particle physics community, is very used to. And strategies like that are very helpful for these advisory committees to see the lay of the land and where science requires these large-scale platforms and investments.
So Dean, we're talking here of both an advisory body, but also, as Kate has suggested, a team that helps really pull this together. And you, of course, have the experience of the synchrotron. So your reflections on this.
Yes, well, the CLS, though a very good machine, is there are many upgrades going on around the world, many billions of dollars, in excess of $7 billion of upgrades going into various facilities, and the CLS is going to be about a factor of well over 100, if not close to 1,000 times less bright than where other facilities are going, and so there's looking at the new machine. It's called CLS2 at the moment. It's not a very creative name, but nonetheless, an upgrade to the facility, a new facility that would allow that research to keep Canadian researchers having the best tools available for that area. But it brings up an issue of where does that fit in? Where does this fit into what Canada really needs? There are competing interests in neutrons. Canada used to lead in the area of neutron research. It started wide areas of research using neutrons, and that capability has gone away, I think, as everybody knows. And I think it's a sin, having come from the U.S. as well, that Canada let that go. And where does upgrading a new facility or building a new facility for synchrotron radiation fit into changes to SNOLAB, what does Triumph want to do? Where does neutrons fit in? I think having a committee or a group, a broad representation group, to look at this from a strategic point of view of what does Canada need in terms of research is critical, because otherwise it just leads to fighting between different groups in some sense. You know, it's like I'm very supportive of the neutron efforts. But I know that there are people who feel we need a synchrotron before we need to go back to neutrons again. And I think that's not the right way to think about it. We need to be supportive of each other, and I think that part, there needs to be some oversight of upgrades, new facilities, and I think as COVID takes its toll and political interest takes its toll, I'm really worried about the fact that I think part of what the Canadian plans seem to be is let's go use somebody else's stuff, and that is getting harder to do. I have several students who cannot go to the U.S. because of political issues there with countries, and I think that as not to look inward to Canada, but I think we need to think about what does this country need to advance science, and to think about itself as well, and what do we need here. And I think that having things here is very important, because it gives us the ability to innovate. When we use somebody else's tools, we lose that ability to innovate in terms of technology, the infrastructure, the experimental design and things. So I think it's important that Canada invest in science here, but it needs some direction on what that should be. And I will be pretty open that I'm very supportive of using synchrotrons to do some of that. But there's, we have fundamental looking for dark energy, dark matter, and so on. I think this needs to be very broad-based and not just photon-centric or neutron-centric. I'll stop there.
Yes, well, thank you, Dean. You, of course, raised the issue that other countries do what we'll call road mapping type activities, which is really a community engaged and government participating as well activity of long-term planning, looking at life cycles. Peggy, do you want to come in at this stage?
Yes, I'd be delighted just to throw out a brief comment. And in some ways, this is going to reflect I think what others are already saying, I think there's some wonderful, pardon the puns again, some wonderful convergence around some of our language in the discussion here. But one thing that strikes me and has struck me through conversations over the last number of months is that there are layers to the way we think about these questions and the recommendations on how we might move forward as a country. And a lot of the recommendations or challenges that are identified usually have to do with either policy on one level and examples we can see internationally about how these might be handled, things might be handled in a slightly better way or with different models. There are governance issues, as I mentioned, around the relationships at different levels. And of course, how the funding is structured, either for the facilities themselves or around the actual research activities. And one thing that struck me over the course of the last number of months is that there's a lot of discussions about what the facilities do or what they're able to do, particularly with regards to some of these large scale problems, however they come to the facility for consideration. But one of the comments that I've heard made is how the current funding models, for example, can make the facilities into it creates a competition between facilities and uncertainty for the facilities and the impacts that that has on the research, but also that the actual constraints that go with the funding that comes to the facility limits what the actual researchers may be allowed to do or what they qualify for. For example, can they apply for insert funding or not? And the impact that has on limiting their ability to contribute. But out of this, then, what I'm hearing more and more discussion about, and it reflects a bit what Dean was just saying, is this idea of the network, not just what facilities do themselves, but how do the facilities work together or see themselves or not as a network? And in thinking of the facilities together as a network, what could that enable as far as collaboration on projects? And certainly Nigel and Kate had some really fantastic examples. I think the ventilator project is really forefront in many people's minds of a unique way that people were able to come together to work and contribute in very unique ways. But that network model, what would that open up as far as input or playing a greater role with government and having more say or more influence in Canada's science agenda, if I can call it that, and how we identify priorities, what funding mechanisms would be regarded as most effective, what would be the short-term or long-term opportunities that could open up. So I'm not sure if others have thought about that in quite the same way, but I'm getting increasingly intrigued by this idea of this network and what that would mean in relationship of the research community with government, with policy decision makers. So.
Thank you, Peggy. I mean, it's interesting. We have an audience question that I'd like to throw out, and it speaks perhaps even more to government, and that's the Canadian government has invested in creating new collaborative science hubs that include multiple departments. And as I recall, they also include academe as well. So what do you see as the biggest factors for getting the scientists themselves, the researchers themselves, on board with large culture changes like this? So that's an interesting dimension to this. Nigel.
So I think one aspect of this is the success of examples that demonstrate that this is a viable way to work, that by drawing people together around these convergent interdisciplinary type of questions, if you can demonstrate that by pulling groups from various departments, various competences, and that allows you to solve the problem, I think that the success of those sort of projects is a very easy way to demonstrate this is a very strong approach to solving problems, and I think people respond very well to that. So the ventilator project, the MVM ventilator project, for instance, obviously it started through Cristiano and Art as physicists, but it connected very quickly into the health sector and into the industrial sector. So we were able to bring together the required components, and that includes regulatory authority, people who are used to dealing with regulatory authorities that physicists have not had to deal with Health Canada before and things like that. So being able to define a problem and then pull together the required components to successfully deliver that problem, I think is a strong influence and demonstrates to scientists that this is a great way to do work and to solve these sort of challenges. I think particle physics generally takes this approach is, what is the problem and what do you need to solve the problem? And if that is something, if that's a piece of infrastructure, or if that's a network of different facilities, or it's a network of different competencies, whatever it takes to solve that problem is the driver. And I think that has it's very easy to demonstrate that this is a successful model for progressing research.
Anyone else want to leap on this? I do have other questions in the queue. So, okay.
Yeah, I think the questions about how to make these hubs successful is really part of it is the funding, obviously. If you can provide, and I think of it from the perspective of running an infrastructure, for the government to get the maximum out of any research infrastructure investment, there has to be a certain percentage of that investment that goes to the scientists and engineers that either use the infrastructure or work on the data. And so there has to be that commitment to linking funding to the scientists who do the research, to the infrastructure itself. And I think that's the same for the hubs. If you can begin not necessarily through direct funding like NSERC and others, but through enhancing exchanges, professional exchanges, academia to the federal departments, actually trying to work on pilots together. So you're testing something together that isn't a big investment, but you can, whatever the challenge is, and then you can demonstrate it, you can show some successes early on at a hub that would help to change culture and help get interest into being part of a hub.
Let's go on to another question. And it's a request for any tips for working with different groups that have very different timeframes that can help ensure a project is still successful. Sure, I fully understand that, but for example, the suggestion is the government, that things that may be slowed down with various approvals. And so I think what we're looking at here is the timeline for decision-making on funding, on planning, may be very different from other timelines, and there may be clashes, etc. So I'm going to turn to you, Dean, to see if you have any insights on what we could be doing differently in terms of aligning timelines and approaches.
Yeah, well, to build a beamline, so this is one of these experimental stations at the CLS, is a massive endeavor, and all of the beamlines short of the initial beamlines were built under the CFI process. And so in a reasonably short time, that beamline is driven by science. What is the scientific problem? What are you trying to solve? But these facilities are typically 10 million, 20 million, even 30+ million dollars to build. And in the normal timeline of a CFI, that is not possible to really price that facility out. So what would be helpful is a mechanism to allow some forward funding for planning some of these large scale infrastructures, so that when it's being built, it's actually built in a way that is compatible with the budget. And so everything is driven by the amount of money. So I think having some more flexibility in determining or being able to plan projects is critical. And I think that part is really tough under the current mechanism. So much so that with the new beamline that's being proposed for the CLS, that process started several years ago in picking it and trying to do as much planning as possible under what you can do with the CFI funding to get a better number for what that takes, because that required an expansion to the building. it goes over some existing infrastructure that's outside the building, and so that takes resources, that takes time. And I think looking at other facilities where if we were to compare ourselves against at the cyclotron in Chicago, for example, that they can build a beamline in like 3 years, 4 years, and it's because they spent 5 years planning that beamline, and then it can be built, very quickly, because that planning has been done beforehand. And so that I think is an opportunity that's missed here, is a mechanism to pick something that you then can commit resources to plan things properly, so that when it's done, it can be built quickly and is still state of the art by the time it's built, rather than it taking us 10 years to build something. So I think for very large things, I think probably that's true of the other CFIs as well. I'm pretty sure that's true of Nigel's and probably Kate's experiences as well.
Yeah, maybe I could add, because I think what Dean is referencing as well is the life cycle being applied to a facility, so that you have a process which would allow you to do the developmental work without necessarily needing to commit to a figure for the final component or whatever it is, the beamline in Dean's case. So having a process that allows you to go through these stages of initiation, development, and then a final costing. So that's the conceptual design review, technical design review sort of process. I would also add, I think this is where the international aspect is also very important, because if you're doing a project, so we're working on trying to attract a large-scale experiment to SNOLAB at the moment, looking at, it's an extension on neutrinos. And this will probably be about $250 million worth of equipment, and it will be a multinational, so many funding agencies will be involved in this. And so you have to try and make sure there is a lot of communication, which is what it boils down to, a lot of communication between all of the national funding agencies who will be working on the experiment, and that includes Canada and the US and other partners, but also couple that to the facility. And what makes the challenge here is it's the projects that we host of this scale are decadal in nature. And so our funding for the facility, you need to be able to demonstrate that you have a credible chance of existing over the lifetime of an experiment to attract that experiment to you. So you then need to tie in the discussions with the funding agents that are involved in the facility. So CFI and the province, Ontario, have been very supportive of SNOLAB. And so we have to build this very complex network of communications across all of the funding agencies, both nationally and internationally, before you can really pull all the threads together and get a project of this scale underway.
And there's been a lumpiness, if I can characterize it that way, in how we've done business in Canada to date. Kate, do you have any insights from the US and other international experience that will be useful in this discussion?
Well, I do think from my experience in the US, there's the national facilities are they're either based in the university system. They typically have a 10-year window. They're funded in 5-year tranches, but the expectation is a 10-year window. And then, of course, there's the national laboratories that have a very, very long life. So there's a rich dedication to it. It has been in the past, and I hope it will continue in the future, in investment in this research infrastructure, both within government labs and in academia, that has demonstrated the success of the U.S. in being a scientific leader. So that's a simple statement. I do want to, there were some other questions I think are really important to close on about social sciences and humanities involved in the infrastructure. Do we have time for those?
That was what I'd like to wrap up with is just how do you engage, and so we'll get you to start on this one, Kate. How do you engage with the social sciences and humanities communities that have typically not been driving or even involved in the initiation of large-scale facilities, but they do have critical roles to play in addressing some of the major research questions? So Kate, over to you.
And I want to come back to the proposal part of funding, just because I think that's where we start. And I do think we have to change the way proposals are reviewed and approved or not approved. And it's from some of the most recent other external agencies I've been funded from, is that you put a proposal in and you ensure that you have as part of that proposal solution seekers or other aspects of who needs this research. And then there's a mentoring process in the review process where the funder actually probes and gets those solutions seekers at the table, which mainly involve a lot of the social sciences and the humanities. And then they become embedded in the research. And that kind of process where you actually are actively helping the proposal become better by including these solution seekers is really important. Ocean Networks Canada, we've done some other interesting things in terms of the arts humanities. We have had programs of having an artists program, and that has resulted in actually some new research that has come out by just bringing them into the program with a very small amount of funding, engaging and having that go forward. And it's been remarkable in terms of what's come out of that. And it's just opening the doors to other people with a small amount of funding. In terms of the social sciences, it's clear the project I just mentioned, every single project in terms of climate change, and that's our big issue of the day, I have to say, will require that the social sciences are involved. And I just gave you an example in our presentation. Social scientists are there to help us go through and provide knowledge to the public, or identify the problems that the public will have, or the regulatory framework, or the investor framework. And so it will be essential that we are integrating social science and humanities in the research efforts around climate change across the board. And that's my soapbox.
Great soapbox. And I'm going to I want Dean to give you just a minute to add to this, because I know you can. And then I want to move to some of our polling questions. Boom.
Yes, well, I don't think I can compete with Kate in terms of the involvement of social sciences directly in the scientific endeavor. But Peggy and I and a colleague, Jennifer Poudre, were part of an earlier project. And I remember commenting to Rosemary Omer, who led a project that involves the Aboriginal and fishing communities in the BC area. Anyway, and commenting, because my background is in X-ray optics, and that my work I never really needed social scientists in my work. And she looked at me and said something that really is why I'm here, and said, "You've never asked a big enough question," which is really true. And I think that's when you ask these big questions, you need people who can actually figure out what are all of the minefield of things, the social acceptance, and being able to deal with communities that we're not used to dealing with. And I think that's where this all becomes very, very important, is in the really big questions. And we see that in COVID and the things going on with the ventilator and so on. You need bigger groups involved for really big questions. And so I think this is a very timely discussion. And did I stay within my minute?
More or less. Now, Peggy wanted to come in. Peggy, do you want to come in now, or do you want to do this in your wrap-up comments?
You know, I could just add very, very briefly to what Dean said. And this always happens. You start talking about great subjects and we always seem to go over time. But all I wanted to add to this is a topic that's really near and dear to my heart about bridging these disciplinary divides. And perhaps because I have degrees that span all of these three spheres of the sciences, social sciences, and humanities. One of the comments that I've often heard is that you can't force collaboration, and indeed that some problems don't necessitate collaboration. And some people feel they really want to make that their starting point, or make sure that's understood. However, they very quickly go on to talk about, to ask the question, how can we get together? How can we find more opportunities or create more spaces for people across these very, to use the rhetoric of silos, how do we give an opportunity, whether it be in a social environment, over pizza, over drinks? that there's a real genuine interest to hear what others are doing, and that can create and open up new opportunities for collaboration. And I think increasingly people realize that science itself, the natural sciences, cannot bring the full answers that we need, that there are social and policy and governance components to these big challenges that we're facing. And what an opportunity we create when people can just get together and talk. So I just wanted to throw that out there, because I'm amazed how often conversations will come back to, is there any funding? Can people make room for funding just for people to get together and just visit and talk about what their interests are, because things come out of that. So I'll just stop there now. Sorry.
Great intervention. And now getting together in a different way. I'm going to turn this over to Joelena, who is going to lead us through some interesting questions.
I just want to say thank you so much for your comments and your questions from the audience. Now we're going to move to another segment which asks you questions about, convergence. And one of our first poll questions, as you'll see that's listed up here, is what is the main challenge or barrier for convergence research to occur? Does it mean limited funding or capacity to make convergence happen? Is it competitive academic and research environments? Is it leadership that fails to foster culture for collaboration? People across disciplines and sectors do not speak the same language or work in silos, and this is a relevant topic that we were just hearing about. Or is it the lack of communication and trust between science and the broader society? And we already have some responses here. Interesting, it's kind of a different breakout. We definitely have a few more talking about looking at people across disciplines and sectors who do not speak the same language. That seems to be a common theme here, as well as limited funding to make that convergence happen. And so we'll move on to the next polling question here. And this question responds to what's the main support or enabler for convergence to occur? Is it having leadership that drives and supports convergence through creating a culture for collaboration? Is it challenges that bring people across disciplines or sectors together to work on a common goal? For example, COVID-19 that we've been talking here and there about throughout the conversation. Is it funding models and mandates that enable convergence? Or is it non-financial mechanisms such as training and engagement opportunities? And so as we're waiting for some responses here, I think it'll fill up in just a moment. There we are. Again, we have a wide distribution here. It looks like leadership and challenges to bringing people together. And again, that resonates very well with what we were just hearing with our panelists. And then we'll move on to question number 3. What do you think are the most effective mechanisms that could be put in place by governments to encourage and support convergence research? Is it more funding for researchers that enable convergence or encourages multidisciplinary teams? Is it a reconsideration of current funding models for national research facilities in ways that support greater research collaboration? Is it greater awareness about the nature and importance of convergence research as a means to address grand challenges? Or the promotion of and training of convergence research applications early in science education programs? Or finally, our last option here is mechanisms to bring together researchers and other stakeholders to develop creative ways to tackle grand challenges. And there we are. We have an interesting split again. It looks like we have a number of people responding to that second option around reconsideration of current funding models, as well as looking at mechanisms to bring together researchers and other stakeholders together. And we have another polling question. It's one of our second to last questions here. And it asks, what do you think would be the most effective mechanisms that could be put in place by research communities and or universities to encourage and support convergence research? And so in the previous question, we were looking at what governments can do, and in this question, we're looking at what research communities and universities might be able to do, or collectively. So in this case, we have option number 1 around cross-disciplinary research opportunities for researchers and scholars in the natural, social sciences, humanities, fine arts, and performing arts to be exposed to each other's disciplines and work environments. Do you find that it's events for diverse researchers and members of the broader public to learn about mutual interests and explore collaboration opportunities? Or is it about building networks across multiple disciplines and an explicit focus on convergence research around a common goal or theme? And we see we already have some results here. And the final was around financial or time release support for researchers engaging in research. And again, it looks like building networks across multiple disciplines with an explicit focus on convergence research around a common goal or theme, and having that interaction. We have that quite a few people who responded to also the cross-disciplinary residency. And moving on to our final question that we would like to learn, how could we connect with you? How can we move this forward? What would you like to see as an action item or deliverable following this panel? Is it to develop a publicly accessible report or presentation that provides possible suggestions for supporting convergence research? Is it developing a working group to further explore ways to support convergence research? Would a follow-up workshop on convergence research for those wanting more tools or models for its applications be applicable? Or no follow-up is necessary. Convergence research has to occur spontaneously or not at all. And it looks like we have 2 of the same questions that are in there. I think the last one was actually looking at distribution of written case studies or models for collaboration, but we can maybe have a quick chat about that. We don't have a quick way to connect with our audience here, but if you have any thoughts around any of these polling questions, if you want to expand on it, or maybe even respond to other options for this final question here, we could use the Q&A as sort of a way to connect that way as well, and we'll be recording that for our purposes and to maybe connect back. And so as we can see, we have a few that would be interested in the publicly accessible report, some votes for developing a working group to further explore and support convergence research, as well as following up with a workshop. So there's some great examples of what might be useful for moving forward. And I think the next point here, we'll maybe turn it over to Peggy and Janet to kind of take a reflection on what we've heard from our audience.
Well, let me just introduce Peggy basically for this, because this session was intended to be part of an ongoing conversation that Peggy is leading on this issue. So Peggy, how do you see the next steps, and particularly looking at the sort of interest here in actual some follow-up, working group or publicly accessible report?
I think this is absolutely fantastic. If I can just situate, I guess, my response to the comments on the follow-up with just some reflections on what we've been talking about. I think there's a clear, it's clear to see from this discussion, and even from the questions that were raised, that there are just such inherent linkages on these notions of the grand challenges we're facing, where Canada as a nation is in terms of its research capacity, and how all of this is so intricately connected to big science and how we approach our major research infrastructure. And so I think what we've heard quite a bit, and it came up in one of those responses, one of those polling questions, was that there is a real need to focus on some of these common challenges, that does present an opportunity or a springboard to think about these collaborative opportunities and what can bring us together as a research community. As I look across the responses, I also sense a real desire to keep this dialogue going, which I think is very much reflected in the responses to the last question, that we could have follow-up in terms of a paper or presentation, something that speaks more to this notion of convergence research. I know there are some publications in the States that have come out from the Academies of Science about how do you foster a culture of collaboration. We might want to think about the Canadian context and what that would look like in our unique circumstance. But secondly, the idea of a working group, that I am very, very excited by. The idea that we might consider, and perhaps this speaks again to this idea of a potential network, but how we might, across our various sectors, whether it be academia, whether it be the scientific research community in the big scale facilities, whether it might be industry partners, whether it might be folks in government. We've talked a lot about public policy and government. How do we start to speak together and perhaps create some sort of a working group or forum where we can think about convergence research in our country? I think, as some of the presenters have commented on, COVID presents a very unique opportunity to think about how these challenges can create opportunities for collaboration in ways that perhaps nobody ever imagined from the outset. And it would be interesting to think about that more, to capture people's experience and perhaps get some of those ideas flowing both through a working group and in written form. So I'm quite open to this, and I'm very, very excited by some of what's being suggested here today. So I'm certainly open to other suggestions building on these ideas as well.
Well, I think I'd first just encourage all of the participants to download the discussion paper and also to touch base with you directly, Peggy, for follow-up, because I agree with you. This is a conversation that we need to have as a country. And our Canadian context is a little different from everybody else's, but that doesn't mean we can't learn from others and then put something into our own context. But I think it's exciting. And we do have just a few minutes left, and I thought it would be useful to go around the table with the all of our panelists. And Dean, your face has disappeared, but your name is still there, so I'm assuming you're still there. Just to get some reactions in terms of the identification of issues that came out of the polling questions, and thank you, Joelena, for all of that. But also any further reflections on next steps. What are the most important and relevant things to do? Nigel. Oh, sorry. I saw. Okay, Kate's hand came up first, so I'll go to Kate.
Okay, so I just wanted to. I think the convergence research around grand challenges is critical. I think that's where convergence will become more important and realize the significance of it. And I do have to say, I agree, COVID is an example, but the biggest issue of our time is climate change. And climate change is partially responsible for the loss of biodiversity and the COVID. So I think we shouldn't just focus on COVID itself. We should really focus on this big challenge that's going to be now central to the United States, hopefully, to Canada, to many of the Western world. And so I think convergence will come of age and be so clear that it's needed to address that grand challenge that we won't have to do much else but help people develop new tools to maximize convergence.
Nigel.
So I was very encouraged with the responses in terms of continuing the dialogue around convergence research and looking at the requirements that would enable and facilitate the sort of work that Kate is referencing. From the perspective of the labs, I think, I just want to reiterate some of the key messages that I've certainly picked up, that the national research platforms, the facilities, they do provide one component of the research ecosystem in Canada, and it's that we have a very strong role to play because of some of the stability in terms of the longevity of the labs and the resources that we can bring to bear. And so I hope that the labs will be fully engaged in this dialogue around how do we build a structure in Canada that can support these large-scale mission-driven type of questions that Kate is referencing. And clearly the engagement of the governments, provincial and federal, is going to be essential in the way that we move this forward.
Dean, I'm glad you're back. So, reflections on where we go from here and what we've heard in our polling.
Well, yeah, I agree. I got lost there. Something, I don't know what happened. I lost my connection, but sorry about that. Yes, I think this is this area of convergence research is here to stay. I think this is essential for us to solve the problems that we face. I think it's a bit of a tricky thing in that I think all of us in the sciences are here because of passion. There's something we're very, very interested in, and I think trying to capture that passion and having it translate to these bigger problems is the tricky bit. And I think that part we need to work on. I think the ventilator project shows that when you realize, I don't think most people realize that you have contributions you can make to these large problems. And I think when you realize you can, I think people are all over it. And I think that's a good example of the passion that people can bring to this, and I think that's one of the missing pieces. We're all human, and the passion piece needs to be captured and thrown at these problems.
Peggy.
Yes, I was. I'm just loving all of these comments, and I was just making a few notes here, and I really liked Kate's comment that I was trying to remember the quotation. I think it was convergence will come of age, and what's important is to emphasize the tools that are needed to enable or facilitate the collaboration. And I really like that. And I think to your point of the different types of grand challenges that we're facing, you know, with COVID-19, as Dean just said, what SNOLAB with so many others was able to contribute in unique or unexpected ways. With climate change, how Ocean Networks Canada is engaged in that in ways that I think Canadians, you know, really it helps their imagination to hear about that and to think about what's possible. And the synchrotron and the work that it's done to contribute now to issues of food or to agriculture, food and water securities, and getting those stories out and greater awareness, and just moving forward, thinking about the ways that we can collaborate further, create forums to move this dialogue forward in identifying and finding ways to address these grand challenges. I'm encouraged by this, and I sort of promise for my part to do. You know, to continue to think about this in the context of the current project, but also in future work, what we might be able to do as a research community in Canada and with colleagues in government and in industry and in civil society to think more about this. So I'm just very, very grateful for the discussion that we've had and for people's interest in the topic.
Well, thank you, Peggy. You know, as we sort of move to wrap up, as we're really coming close to the witching hour, we've talked a lot about one C, that's convergence, and another C, which is challenges, grand challenges, obviously, but also micro challenges in terms of structure, approach, policies, and governance. We've talked about connections and the importance of just sitting together, even if it's in a virtual mode, the importance of connection. But a word we haven't heard as much today, and I want to end on, is culture. Because I think we have a culture here that is changing with our recognition of the power of convergence, and a culture that I hope is going to increasingly be influenced by the innovation, the imagination, and the reach of these national to international resources in our national research facilities. It's the people there that are going to be the culture drivers, the changers. So with that, I thank you all. It's been a great panel. A particular thanks to the organizer, Peggy, and the Center for Science and Innovation Policy, CSIP. Panelists have been wonderful. I would also ask those who have participated in the audience to also participate in the post-session survey, which I believe is supposed to pop up on your screen moments after the end of this session. So again, many thanks.